Among the science luminaries at their height in the revolutionary early 20th century, Einstein, Heisenberg, Schrödinger, was Niels Bohr, a physicist who redefined how we think about atoms and electrons and enabled chemistry to make a quantum leap into the modern world. Niels Bohr was born in Copenhagen, Denmark in 1885. His family was nerdy. Bohr's father was a university professor who was nominated for Nobel Prizes, while his sister became a teacher and his brother was a mathematician. Two of Bohr's own sons grew up to be scientists as well, and one of them, Åge, won a Nobel Prize in physics. Talk about your family traditions. As a kid, Niels liked to tinker, fixing watches and bicycles. In high school, Bohr gravitated to physics and bonded with chemistry. He was a prodigy, finding errors in his textbooks. In college, he was apparently known not just for his brilliance, but also for his habit of breaking glassware and blowing things up in the chemistry lab. He once set a record for most broken glass in one semester. Where Bohr really made his mark wasn't in the lab though. As he moved through graduate school, Bohr became more and more interested in theoretical work, the stuff of equations more than Erlenmeyer's. He left Copenhagen for England, where he worked with some of the top chemists and physicists of the day, like J.J. Thomson, who discovered the electron, and Ernest Rutherford, who was figuring out what makes up atoms. Rutherford's famous gold foil experiment proved that atoms had a small, dense, positively charged core, seemingly surrounded by lots of empty space. Based on that idea, Rutherford theorized that atoms had a nucleus at the center and electrons whizzing around it, kind of like planets around a star. Bohr spent just a few months with Rutherford, but on his return to Denmark, he started working out the theories he's remembered for. In 3 papers known as the Trilogy, Bohr showed that the electrons in Rutherford's model had to be at fixed distances from the nucleus. Bohr's theory was based on recent research in physics by the German genius Max Planck, among others, that showed energy could only move in specific amounts, or quanta. You know, that's the plural of quantum. This was a revolutionary idea compared to classical physics that Newton and others forged out, where balls flying through the air arc in a continuous path, just like planets moving around a star. Nope, in quantum theory, particles could only exist in specific places where the energies are allowed, which seemed, well, weird. Bohr adapted this quantum thinking to the atom, showing that electrons fit into different energy levels. The electrons could jump between these energy levels, moving to a higher one by absorbing a fixed amount of energy, or moving to a lower one by releasing that fixed amount of energy in the process. At first, other scientists didn't think the idea of energy levels made any sense, but it was incredibly good at correctly predicting natural phenomena, unlike models that came before it. Take the characteristic spectrum hydrogen produces when it's electrified. These lines have been described experimentally, but no one was sure why they appeared where they did. It was only when Bohr applied his theory of energy levels to it that he could explain how each line corresponded to an electron moving between energy levels, but never in the middle. Atomic spectra had been a map of how the atom works all along, but no one knew how to read it before Bohr. For building this eminent understanding upon the strong foundation of Planck, Bohr received the 1922 Nobel Prize for his atomic model. Planck had gotten one 4 years before in 1918. But this was hardly the end of this Great Dane's scientific career. It was an incredibly rich and dynamic time in physics. Bohr discussed the latest theories and discoveries with Erwin Schrödinger, Werner Heisenberg, and Albert Einstein. And later in his life, Bohr came to accept the evidence for a universe based largely on the rules of probability and quantum mechanics. Ironically, as he and others came to understand this reality, a newer theory of the atom emerged and replaced Bohr's as well. After all, his model turned out to only really work for hydrogen, not so much for the rest of the periodic table. But the atomic model theories that replaced Bohr's would not have been possible without his clearly showing quantum mechanics had to be incorporated. It was also a dangerous time in Europe. As the Nazis gained power in Germany, Bohr helped scientists there flee to institutions around the world. And when Hitler invaded Denmark in 1940, Bohr famously thought to dissolve the gold Nobel Prize medals of two colleagues in acid so they couldn't be stolen. They sat in a jar on a shelf until after the war, when the gold was recovered and the medals remade. Bohr himself fled to Sweden because of his mother's Jewish roots. Before leaving Sweden for England, Bohr met with the king about the plight of Denmark's Jews. Shortly thereafter, the Swedish government helped organize a massive rescue of thousands of Danish Jews.